we have a similar situation here with x squared plus 25 equals 0. In the last example, c was equal to 0. This time, really, we've got b equal to 0. Since there's no x to the first term. So a is equal to 1, b is equal to 0, and c is equal to 25. So plugging that in, negative 0 is still 0. Let's see, 2 times a, 2 times 1, 0 squared minus 4 times 1 times 25 taking care of what I just said about negative 0 is still 0. 2 times 1 is 1. 0 squared is going to be 0. There's only one negative. 4 times 1 is 4. 4 times 25 then is 100. 0 minus 100 is negative 100. And so we have plus or minus square root of negative 100 all over 2. Splitting that up into the perfect square of 100 times negative 1. And applying the quotient rule, the product rule for radicals. Square root of 100 is 10. Square root of negative 1, referred to just a little while ago, is the imaginary unit I, and that'll reduce to plus or minus 5i. But if the directions don't tell us that we have to use the quadratic formula, it would have made a whole lot more sense to move the 25 to the other side and apply the square root property that would cancel the squaring on the left. Can't forget the plus or minus. And we come up with plus or minus 5i much quicker. Once again, the quadratic formula solves all quadratic equations, whereas factoring cannot. The square root property cannot. But it's not always the most efficient thing to use.